Hello. We had quite the trouble with Zoom today, and all just because I needed to switch over to look at the calculator. So I'm going to just start recording where we left off, so we can kind of continue. And I appreciate your patience, and thank you for sticking with me. I know there just might be some of you that join here, but we were looking at this problem. And the last part was a little bit different kind of one. Now the first one, you look for the starting number and you either add or subtract depending on if it's growth or decay. We've gone over that over here. If you see growth, appreciation, or increase or earning, then you're gonna add the rate as a decimal. If you see depreciation or decay or something going down, then you subtract the rate. And so this problem with the car, and this happens with the value of cars, is they will depreciate. The values go down. And we had come up with this formula, and then we were trying to guess how long it's going to take before the car is worth $1,000. And we kind of did this, but it was very rough. So let me go through again. I don't want to stop that video. I want to switch over here. And this time it should switch. I think I've got the bugs ironed out. And so I'm in menu one, menu one of the Casio, which is it should say, what is it, math? Right here. So my formula is 25,000 and then 0.84, and that represents a 16% depreciation. And what I had figured out that at 10 years, it's about $4,000. It started at 25,000 and it's going down to 4,372. So I'm just going to start guessing until I get to, I'm trying to see how many years, so the 10 is the years. How many years will it take for that to get to 1,000? So I'm gonna, if that's 10 years, then I'm just gonna keep using this formula. Then I guess 15 years. I still have the same starting amount. This still represents the 16% decrease. And then for 15 years, which is just my next guess, it's 1,828. So let me keep guessing. Then first I had guessed 17 years. Let's just check out a few more. So then we checked at 17 years. And we're getting close because this is 1,290. So let me just, always got to double check my zeros. Maybe one more year, 18 years. And there it's pretty darn close. 1,083. Let me just see one more year what it gets to, 0.84. And that's 900. So it's somewhere between, it's about 18 years, or you could say between 18 and 19 years. And we're just using that formula over and over to guess. Is the strategy there on that one. I'm going to share. And so down here, I don't have much room to write this, but it's about 18 years. Right. About 18 years. So, and this number 4 is a little bit different kind of problem. This one is looking at, let me put, yeah, here, hopefully I'm in the side view here. If you, this is how much do you need to invest? And this is what we're asking for here. How much do you need at the beginning? So we're, this time they're not telling you the starting amount. Now what I want to do is the result is $20,000. I want to see, I want to get $20,000 in 5 years. And here's my interest rate. So this one is even a little bit more different. So Y equals, I don't know the starting amount. And sometimes that's called the principal, but we're just going to call this A right now. And is it 1 plus or 1 minus? Well, since it's interest rate, interest is what I'm going to earn. I'm going to invest money to earn money. So this is 1 plus the rate. So now I have to calculate the rate. What I need to do is convert this to my decimal. So I'm going to take, I see a decimal point. I'm going to move it 1, 2. Now this one I need to add a 0. Edit this one. So it would be 0.085 raised to the x. But I know that, I do know the x, I knew the amount of time, it's 5 years. So this is what we're starting with. I don't know the starting amount. I do know that it's 1 plus and there's a rate in 5 years. And I do know what I'm supposed to get. I want to get from this, I want it to be equal to $20,000. So you have to read this one very carefully. Because what I'm looking for this amount of money. So I want to keep my eye focused on what do I want? This is the what I want. So I need to get rid of what's with that. And it's being multiplied by this amount. And I could certainly simplify this. But basically what I need to do is divide both sides by whatever that is equal to. And the trick is you really don't need to worry about it just yet. 1.085 raised to the 5th. I did go ahead and add this 1 plus that much, and then it's going to be divided by both sides. And this way I can cancel this out and I'll just be left with the A. So I'm going to go to the calculator. And let's see if I can switch that over. So I'm going to show you what I'm going to do on the calculator. Always push the wrong button first. You know, it's going to switch over in just a second here. And so I'm going to start with the 20,000. And again, when you put the large numbers into the calculator, you don't put the comma. And then I'm going to divide by. And I'm going to put the parentheses, 1.085 raised to the 5th power. So this is taking the big number and I'm dividing it by that. And so I would need to start with about $13,300 in $1. So this is the calculation that's happening. And let's go back to our problem. So when I divided this out, this is what I just did in the calculator. 20,000 divided by 1.085 to the 5th power. And so what I end up with is my initial amount, the starting amount that I need to get that money is $13,301. Oops, I need to put my dollar sign in. And so that one's just, that's how that works. So there's some, let me look at the problems that are assigned for today in Google Classroom. I may shorten this up since we had kind of a crazy class time, and we'll do, I am going to go ahead and I think finish this one out. This is Tuesday's work, and I'm going to go ahead and post all of this out. You know, you work at it, make sure you do turn something in, you make some kind of a connection today. If you've attended Zoom at all, you've made your connection for today. So there's a couple of you that need to turn something in or make some kind of connection today with me. Let me know that you're watching the videos, what have you. So we finished that. What I wanted to do next is kind of take a look at some of how this graphs. So we've got some practice here, and some of the questions are like the ones we've looked at. Again, if it's plus, and that this number here, the number in the parentheses, or the number that's got the X to it, it may not have parentheses, but that number that's here to the power, if it's more than 1, we call it growth, and if it's less than 1, it's decay. And we've talked about that. These are some ones that we had done the other day. What I didn't get to do is do some of these ones here that have to do with the graph. And so I want to look at the graph and then make sure that you've become familiar with this word. This is a brand new word, perhaps for you, asymptote. So what is asymptote? We've talked about domain and range. And this domain and range is listed a little bit differently than you'll probably get. But we want to look at the y-intercept, the domain, the range, and the asymptote. Now, I'm not going to worry so much about some of these answers because we're going to put them in our own answers. This is going back to the first one we looked at. This is the formula. I'm going to put it into the other format. Y equals, I'm starting at a 1, and then it's multiplying by 2 each time. So this first 1 is invisible when you see it like this. But this is the starting amount, and this is what's happening. It's doubling every time. Now doubling, well, let's talk about doubling for a second. Doubling, oh, let me get that. Doubling is when it's times 2 every time. It's times 2 over and over, over and over. But it's also increasing by 100%, and I'm going to show you that. So if you double something, you're getting 100% increase. And let me kind of, I don't know if you get to see my face rather than the calculator, if that's better. And to get this large, the other stuff is so tiny that I have to kind of guess where it is. Let me just start a new one. So doubling represents an increase of 100%. And let's see how that works. So if I'm increasing at 100%, let's use this formula that we're using before. What I'm going to do is take that percent and change it to a decimal. So we're going to do the same thing. I'm going to find where the decimal point is, and since I don't see it, it's right here, and then I'm going to move it back 1, 2. And notice it ends up between the 1 and the zeros. So if I'm going to use the other formula, y equals what I'm starting with, and let's say I'm starting with a 1 in this case, and then I'm going to go 1 plus 1 raised to the x. And that's how you, because the 100% represents 1. A big number to a very small number. And it sounds tricky, but that's exactly what it represents. You're getting 1 more of what you had. If you have 1, then I add another 1, that's 100% increase. And that's doubling. And the formula ends up looking like that, which is what we have here. This represents doubling, means I'm multiplying by 2 every time, and this represents a 100% increase. And so what we're going to do is take a look at the graph, and I'm going to do my best to do a graph right here. And at 0, this is my starting number. So at 0, it's 1. And then at 1, it's 2. This is 1 and this is 2. Now every time it goes up, so at 2, it's 4. It looks like a 3, but that's a 2. Now 3, the 4 goes to 8. And then at 4, the 8 goes to 16. So as we go up, and this is the starting point. Now when I say starting point, I'm talking about the y-intercept. That's this point right there, the 1. Now from here, 1, 2, 4, 8, 16, it keeps increasing, keeps doubling every time. But when I go to the left, it would be half. So this would be a half, this would be a fourth, an eighth, a 16th. What's happening is if I keep traveling along the x-axis, so the x-axis, you have to picture it going all the way over here. The graph of the line is getting closer and closer and closer, half, 16. We keep halving and halving and halving, but we never get to this 0. So it's going to get right to that, but it's never going to actually touch that x-axis. It's going to skim closer and closer and closer and closer, but it's never going to touch. And what we end up with is this invisible boundary. And sometimes they'll use a dotted line. I wish this was a darker red, but it's a red. Make it a little darker. And I'm using the dashed line with dashes, dash. And it's exactly the same place as the x-axis. So as this goes to what we call negative infinity, it's going forever in the negative direction, the y is getting closer and closer to 0. It's approaching 0. Now, as I go to the right, as the x's go to the right, they're going into positive infinity. So as x approaches positive infinity, y are getting bigger and bigger. They're going off into infinity in a positive direction. So what is the y-intercept? The y-intercept is the starting point. And this is the point, I'm going to go with my x first, 0, 1. So this is the y-intercept. Now the domain, I look to the left, how far to the left, how far to the right. It goes forever in both directions. And this is the way that it will probably be stated in the work that you're doing. Now, as you get more advanced, they may call that something else. And what it is we're going from forever to forever. But forever has two directions. Forever has a negative direction and a positive direction. So for this one, there's the answer. Now, on all work that you're going to be asked to do, you're just going to say all real numbers. Or you might see that fancy R, but not usually. Now let's look at the range. So the next one here is, what is the range? So the range, we're going to think how far down and how far up. Well, if I look, I can look quickly right here, and it's going up forever. You know, it's going up and up and up. But when it goes down, it hits this barrier, this invisible line. And so it never gets past there. It goes to 0, but it never gets there. So really the way you're going to learn this, and this is what's required at a high school, intermediate math level that you're at. We're not advanced math, but we're doing we're not beginner math either, is that y is greater than 0. It starts at the 0 and it's getting bigger. Let me show that again with a different way. It's the y's get close to the 0 line, and then they're going up from there. And so as you go up, that's the greater than. Now in this case, remember we said sometimes the 0 is included. Well, the 0 is not included. I'm not going to put the little line underneath like sometimes I'll do. It's not there. It's just greater than 0. At the 0, what I have is this dotted line. Whenever you see an open circle or a dashed line at that point, then you don't put the equal sign with it. So this is the domain and range that we're learning with. Now I'm just going to circle the answer that goes with that, but you don't need to learn this right now. It starts at 0 and goes to infinity. It's that one right there. But this is what you need to learn right here. Worry about this. Don't worry about these, all these sideways infinity signs. So this is perhaps a new word for you. Like I said, the asymptote. The asymptote is the name for this invisible line, and it's very much related to the range. So the asymptote is this line. Now it happens to be the x-axis, but I need to find the equation for the line. Now for the equation for any line that goes horizontal is y equals. And what is y equal right here? Y is equal to 0. Now that, we'll look at some where mostly the asymptote, the invisible line, is going to be at y equals 0, but it can shift up or shift down. And we'll look at some other ones like that. But this is, I know this looks like a big mess now, but we've looked at the y-intercept is the starting point. I don't want to mark all over this. The y-intercept is the starting point. Now notice here it's invisible. You don't see that 1, but it's there. It starts at 1 and then goes by 2. And then once we get the graph, because this is the graph for these exponentials, so we're looking at a little bit different kind of problem here. So let's look at this one here, number 2 on this practice, and we're looking at some stuff with the graph. Which of the following statements is not true regarding the exponential function y equals 2 to the x power plus 4? Well, let's look for a minute at this formula. Now we see the one we just started with, the y equals 2 to the x, which is that graph. Let me see if I can just sketch it. I'm going to do a sketch of that graph. Y equals 2 to the x is the one that goes like that, something like that. It keeps going like this. And it has the asymptote right here, or the invisible boundary at the x-axis, which is the line y is equal to 0. So that's this part here. And that could be considered the parent function. So tell me, what do we know about this part when there's a plus 4, and look at where the plus 4 is. Is that plus 4 at the beginning? Is it inside with the x? Or is it at the end? Think about what you've remembered about transformations. Now, if I want to graph 2 to the x plus 4, if you thought about this shifting up 4, you're right. It's gonna, now what's gonna shift up? The asymptote. So if this is at 0, 1, 2, 3, 4. If I shift it up to 4, what shifts up is the asymptote. And then this graph is just, it's the same graph, it just went up 4 spaces. So now we've got some questions to look at. So we did a little study of this graph. This is just the regular doubling function. That's the most common exponential function, is where it doubles every time. And then we shifted it up 4. And so we're looking at this red one. Let's see if these statements are true or false. We're looking for the one that is not true. So the first one says the domain is all real numbers. So I'm going to look at this red one, look to the left, look to the right. Well, that's true. This is all real numbers. The average rate of change is constant. Well, that doesn't sound right. The rate of change is the slope. It's the same thing as slope. And the rate of change is constant for linear functions. For exponential, it's always changing. It goes up 1, then it goes up 2, then it goes up 3, then it goes up 7, then it goes, you know, it's going up at a different one. Well, let's see. So this one we're not sure about. I'm gonna look for the trues. You know, this one is true. This one we don't know. The third one, the y-intercept is at 0, 5. Well, where was it? For 2 to the x, what's the starting point? Well, it's at 1, but I've shifted up 4. And, you know, this is not a perfect graph, but it will be, this would be true also. Because if the starting point was at 1, and then I shifted up 4, that will end up at 5. Now the asymptote was at here. The asymptote was at the 0, and it also shifted up 4, And so that is true. So the answer that is not true is this one here. Not true. The average rate of change is not constant. The average rate of change in linear is constant, but not for exponential. Exponential is always changing. Okay, now we're looking at, we're doing some more look at graphs. So this one, let's take a look and see what you can think about this function. Now here's the main part. And what's invisible here? A 1. So it's starting at the 1, but then we shifted it up 2. So it can't be this one. I'm going to eliminate this one because this one did not, it starts at a 1, and but it didn't get shifted up 2. This one could be. This one could be. This one's too much. This one went up to the 4. It's either this one or this one. So we're going to look at, is it increasing or decreasing? It's increasing. If I'm going times 3, this is the B part. The 3, the A, the starting point is invisible. It's the 1 times 3. And this is the B, and it's more than 1, so it's increasing, it's going up. If the B was less than 1, it would go down. But here, the B is 3. So this would be the correct graph. We've done these. And this is a really great one, and I'm going to look at the graph here just on another page. We're given 2 functions. One is a linear function, which is 3 to the x, and the other one is exponential. I said this one wrong. The linear function, which is 3 times x, and an exponential, which is 3 to the power of x. Which function has a constant rate of change? And we studied this back at the beginning, and these are on these notes. The linear has the constant rate of change. The exponential, the rate of change or the slope is changing. It's got a lot of slides here. Oops, I went too far. Or did I? Or did I? So with a constant rate of change, that's linear. Now, B is in some language, it's a little bit more along the lines of calculus. I'll briefly go over it, but this will not be on any test that you have in a math models class. It's more advanced, but it's saying at the end, as y increases towards positive infinity, as y gets bigger and bigger, has this at the end, that at the end, y gets bigger in a positive direction and x gets bigger in a positive direction. It's actually both of them. And I'll talk about that just again briefly. I'm not going to spend too much time on that, but I won't ignore it either because some of you are going to get it. Which one increases at a faster rate? You have a guess? It's exponential. Which function has a y-intercept at 0, 0? Well, let's take a look at these graphs just for a second, kind of look at that. Now, I'm just going to do a very simple sketch. Now, 3 to the x, y equals x is the line that goes here. Y equals x is there. And this one is 3 to the x. It's been stretched, so it's going to be a little bit steeper. It's someone at the top is stretching it, and so it's going to go a little bit more like that. What I have is from it starts at 0, 0, and it goes up 3 over 1. That's the slope right here. Rise for 3, run for 1. Rise for 3, run for 1. Rise for 3, 1 for 1. So it's this line here. And so this is the y-intercept. It's invisible this way. mx plus b. So b is the y-intercept, and it's this number here that we don't need to really write that plus 0. As far as the exponential graph, so 3 to the x, what's our starting number? The starting number is an invisible 1. 1 times 3 to the first. So that's your y-intercept on this one. And then each time is going to multiply by 3. So 1, I go up to 3, and then 3 times 3, 9. 3 times 3 times 3 times 3, the next one is 27. It's so far up here. And then it's going to keep going down, down, down here. What we have again is this invisible boundary at y equals 0. It's still at y equals 0. And I can tell that the asymptote is the same because there's nothing here. This is where you see the asymptote. And that's if it gets moved up and down. Okay, you're not going to be able to see that. Let me type that word very clearly. Let me type it better with a text box. Asymptote. And it's just a fancy name. It's just this invisible boundary or line that it doesn't cross. And there's nothing being added or subtracted here. So let's go back. The main question we were looking at is the y-intercept. And this y-intercept is 0, 0. This y-intercept is 0, 1. So the y-intercept on a line is that it's the number that you add or subtract with the x term. The y-intercept here is the beginning number that gets multiplied. And when it's 1, it's just invisible. So which function has a y-intercept of 0, 0? The linear function. Now I did talk about looking at the asymptotes. And here you see the asymptote. So this asymptote is at y equals 2. That means the invisible line that's usually down here at the 0 got shifted up 2 spaces. I didn't draw it very well, but there's the asymptote. And you can see it if anything's being added or subtracted. That's the only way you can get the asymptote to change, because it has to move up or down. We've done a bunch of these. We're going to skip that one. We don't need that one. That is the main thing that I wanted to do. So you've got one more set of practice problems to do. We did the Jamboard. These are the problems. It's on the Word document. And you can see the first one is about the graph. An exponential function's graph below. And so look at the y-intercept. The y-intercept is here at the 2. and look at where the asymptote is. Did it shift? It did. It shifted down. So this asymptote, it's touching right around the -1. Let me see if I can. I'm not going to go through these in detail. We'll come with your questions on Thursday. But do your best to study through these, find out what your questions are, and you know, these are tricky, but you start learning a few tricks and you'll get there. And everything takes a little bit longer to, you know, when you're learning something, it doesn't all come at once. It comes little by little. So I appreciate all your hard work and appreciate your patience today with the video. And let me know if you've got questions as you work through these. I'm happy to log on or to give you any kind of quick answers that I can. I know I didn't get to some of those that I meant to on Thursday and Friday, but keep asking and I will do my best to get back with you. And I know that you guys are also looking for an update of Skyward. That's my first priority to you all today, is to get your Skyward grades updated. Cross my heart. And thank you and for all your hard work. Bye-bye.